Hello, thank you for watching this video. So this video I'll be doing question 6 of May, June 2022, question paper mathematics paper 2. The topics are the trigonometric functions. So I'm going to read question 6 statement and then answer the questions that follow. So let's go. They are saying in the diagram, the graphs of f and g are drawn on the interval for x is from minus 180 degrees to positive 180 degrees. The graphs intersect at N, P, and Q. They are saying P is also the turning point for both graphs. So, as you can see here, you have f, the function f defined by f of x equal to cos x plus a, and g of x defined by sine 2x, right? And these two functions that are drawn for x is from minus 180 degrees to positive 180 degrees. As you can see, from minus 180 degrees all the way to positive 180 degrees. No problem. Then they went on to say that N, P, and Q are points where your graphs intersect. That's what they have told us. And also they told you that P is the turning point for both graphs there. That's what they told us. Then what else are we told? Also you can see that the red function here is G. So G defined by sine 2x is the red function that you can see over there. And then now f of x, which is the blue function, you can see here f of x is this blue function over here. It's defined by f of x equal to cos x plus a. That's all you need to know from that. So you can see that the coordinates of n are incomplete. You have the x coordinate, but you don't have the y coordinate. The coordinates for P are complete. The coordinates for Q are also not complete. You have half the coordinates. You have x as 45. What? Can't be 45. It's 165. So you have x as 165 here. And you have k as the y value. So this k as the y value is the same as that one, right? What does this mean? Because it's k here, the y value is k, and the y value there is k. If these two have the same y value, this means that these lie on the same horizontal line. These two, this point N and this point G, they can be joined by a horizontal line. So this line of yours is parallel to the x-axis, it's horizontal. No problem. So let's go to the first one. What are they saying on the first question? They're saying, write down the period for f, right? They want us to find the period for f. What is the period of a function? The period of a function, I'll say, is a duration for one complete oscillation, right? For one complete oscillation. So, where is f? F is this blue function over here, right? So, how do you find a period for a function? To find a period for a function, you can look for it, right? You can look on your function, or you can calculate it straight away. So, if you have, let's say, you have y1, right? And y1 is defined by a cos x plus p plus q, maybe. Then, and maybe you have y2 as well, to be a sine. Actually, this doesn't look very nice. A cos kx, right, plus p plus q. And then let's say we have y2, and y2 is defined by a sine what? Sine kx plus p plus q. The period for both of them, right? For both of them, for, let's say for y1, you calculate it by, for y1, which is the first function, which is this, or maybe for y2, it's going to be 360 divided by k. What is this k? This k is this coefficient of x here. Not that k over there, but it's the coefficient of x on your function. Then, if you have y3 to be equal to A tan x, kx, plus P plus Q, maybe. The period for y3, for this function now, which is y3, would be equal to what? 180 degrees divided by k. That's how you calculate your period, if you can look at it from the function straight away. Right? No problem. In this case, they want us to find the period. They want us to find the period for what? For f. What is f? F is defined by f of x is equal to, where is f of x? Here is f of x here. It's cos x plus a. Here is f of x. F of x is defined by that. Right? No problem. So what do we do? What do we do from here? So this f of x is equal to cos x plus f of x is equal to cos x plus a, right? So this here is similar to the first one, y1, if you look at it. You can write this as y1 if you want. And say maybe your f of x is equal to, you want to write it this way. What is your y1? Your y1 is y, right? A is the coefficient of sine. What is in front of sine? Sorry. A is the number multiplying cos. What is that number multiplying cos? What is it there? It's 1. So it's 1 cos what? Kx. What is the coefficient of x there? What is the coefficient of x here? It's 1. Right? Plus p. What is the p? Is a there. So actually, so the coefficient of x is 1. So what we have here, we have cos 1x. This is 1x here. Plus a plus q. Right? Because we have q. What is q? Do you see anything there? No. So we have 0 there. So if we want to calculate the period of this thing, here is it. Which means we want to calculate the period for f, right? So the period for f is going to be 360 divided by what? Divided by the coefficient of x, which is k, because 360 over k. What is your k? Is the coefficient of x. What is the coefficient of x? The number in front of x there is 2. So it should be 360 divided by 1. So it's not 2, it's 1. So what you're saying essentially, to find the period of a sine or cos function, it would be 360 divided by k. What is k? K is this number in front here. And what is this number in front here? And the number in front here is 1 in that case, as you can see there. So it would be 360 over 1. And the answer to that is equal to 360. So the period for f is equal to 360 degrees. That is where we are. Right? No problem. Then we move to the next question, which is 6.2. What are they saying? It's 6.2. They are saying write down the amplitude of G. They want us to find the amplitude of G. What is the amplitude of G? Or what is the amplitude of a function? The amplitude of the function is the height of the function. How high is this function of yours? Right? No problem. So where is G? G is the right function. So G is oscillating around this point here. Is moving around y is equal to 0. G, you can see, it's moving around y is equal to 0. Its axis of rotation is this line here. It's moving around this line. Because what you want to measure the height of this thing. So to measure it, it's going to be measured from the axis of rotation to the highest point. That's how you're going to find the amplitude of this function. So in this case, the axis of rotation is this line here. So we're going to measure from the axis of rotation to the highest point there, which is what? It's 1 unit, because the highest point is at y is equal to 1. So the amplitude is equal to 1 unit. That's it. because it's the height of this wave or this function of yours. And this height will be measured around from the axis of rotation to the highest point. That's how you find your amplitude. Or maybe, if you don't want to, it's okay. You are looking for this amplitude of G. What is G? G of x is defined by what? It's defined by sine 2x. The number that is in front here of x, of sine, is your amplitude. For sine and cos, at least. For these two functions, these two, this and this is your amplitude. So what is the number in front of sine there? It's 1. So you could have looked directly from this and see that your amplitude is called 1. That's the second way maybe you could have looked at it, if you don't want to measure it from here or maybe from there, because here is still the same thing. It's 1. Also, you could have said, okay, my amplitude is equal to my maximum y value minus your minimum y value, all divided by 2. Then you say, okay, what is my maximum y value? My maximum y value is 1 minus the minimum value, which is minus 1, because the minimum is the smallest y value, who is here, here. The maximum is over there, all over 2, and the answer is 1. So your amplitude is equal to 1. Right? No problem. We're done with 6.2. We're going to move to 6.3 now. Okay, so now we're doing 6.3. They are saying, write down the value of A. What is A? A is this value over here. So you are given a 6.3. That f of x is equal to cos x plus A. That's what they gave you. Right? So they wanted to find the value of A. Right? As you might know, if you are given an equation, like maybe y is equal to 2x plus 7, or let's say plus c, in order to be able to find that one unknown value there, you need at least a point, right? You need a point so that maybe if you have 2 and 7 as the points on this line, you substitute your x there and substitute your y there. So this is a similar scenario, because you're only missing one value there. So what you should do, what you need to do, you need at least one point on the line, on this function f, and then substitute its y value and its x value. You'll be left with A is an unknown. And then you solve for A. That's what you need to do. That's what we're going to do. So let's do that. Look at our function f. Are there any points that you can clearly see there? Here is f, here is this blue function that on this point. And you have p there as a point on f as well, because p is a turning point for both functions. That's what we were told. So what do you say? So okay, I have p, and p have coordinates 45 and 1. So this is your x coordinate and this is your y coordinate. So substitute this x here and substitute the y there. So your 1 is equal to cos 45 plus A. Right? No problem. Then take arc cos of 1 is equal to 45 plus A. What is arc cos 1? Arc cos 1 is equal to 0, right? Arc cos 1 is equal to 0. So 0 is equal to 45 plus A. Therefore, solve for A there. Your A is equal to minus 45 degrees if you take this A and transpose it to the other side. So your A is equal to negative 45 degrees. And we're done with 6.3. We'll move to 6.4. What are they saying at 6.4? At 6.4, they are saying, calculate the value of K, right? The y coordinate of N and Q without using a calculator. They want us to find the value of K, right? The y coordinate for N and Q without using a calculator. Where is K? K is this point over there, right? It's the point over there. So they want us to find the value of K. How do we do that? This point lies on maybe this function here, f. And we know that f of x is equal to what? It's equal to cos x plus a. What is your a? Your a is 45. So it's cos a minus 45. So f of x is equal to cos x minus 45 degrees. Because your a is 45. So you didn't know a before that. Right? So k lies on f and also lies on j as well. Right? So it doesn't make too much difference. So what we can do is, we can say, okay, we have the coordinates for n to be minus 75 and what? Minus 75 and k. So we want the value of k. So k is the y value and this is the x value. So we substitute this on our f. Because this lies on f, we can also do the same thing for j as well. Right? No problem. What do we have? We have that your f of x, which is y, is k, is equal to cos x. What is your x? It's minus 75. Right? Minus 45. That's what we have there. So, what is that? Minus 75 minus 45. Negative 75 minus 45. That's minus 120 degrees, right? So, what do? So, okay, my k is equal to cos negative 120 degrees, right? So, what do in this case? So, because it's negative, right? Add 360 to it. So, we're going to add 360 to this. So, you say, oh, minus 120 plus 360. What do you get? You get 240. So, k is equal to cos minus 120 plus 360. Right? So, k is equal to cos 240. So, where is 240? 240 is on the third quadrant, right? So you try to write this as an acute angle. So say, okay, k is equal to cos 180 degrees, right? Plus what? Cos 180 degrees. What do you add to 180 degrees to get 240? You add 60, right? No problem. Then when you get here, you ask yourself, where is 180 plus? It's on the third quadrant. What sign is cos there? Your cos is negative, so you get negative cos 60 degrees. And cos 60 degrees is equal to half. So your k is equal to, because k 60 is a special angle. So your k is equal to negative half. Done here. So yeah. Could have maybe been easier if you used g instead of f. So your k is equal to a negative half. And we're done with 6.4. I'm going to clean the board and we do 6.5. Let's clean the board. Okay, so now we're doing 6.5, right? 6.5 reads as follows. They are saying, calculate the value of x if g of x plus 60 degrees is equal to f of x plus 60 degrees on this interval here, right? They are saying, calculate the point of intersection of g of x plus 60 degrees and f of x plus 60 degrees on this interval. That's what they are saying. They want you to find the point of intersection of g of x plus 60 degrees and f of x plus 60 degrees on this interval over here. No problem. How do we do that? So they want the point of intersection of g of x at 60 degrees and f of x plus 60 degrees. Now, the question is, you had g of x to be equal to what? Your g of x, you're given that it was equal to cos x, and you found that your a was 45, right? And then now, you are given this thing here. What is this thing? This thing here is what? This thing is g at x plus 60 degrees. The question now is, what does this thing mean? What does this thing mean? This g at x plus 60 degrees. What this thing means, it means your function g has been shifted horizontally. This thing here, it means your function g have been shifted horizontally, either to the left or to the right. That's what you know when you see something like this. To decide if it's shifted to the left or right, what do? You equate this to 0, this part in the bracket to 0, and solve for x. So you say, okay, my x plus 60 degrees is equal to 0. And then when you solve for x, you get your x equal to minus 60 degrees. Right? So if your x is equal to minus 60 degrees, it's negative. It means this thing has been shifted. So g is shifted 60 degrees to the left because it's negative. So your function g is shifted 60 degrees to the left. Right? No problem. You had f of x, and your f of x was called what? It's equal to sine x, sine to x, right? Now you have f at x plus 60 degrees. Question is, what does this thing mean again? The same thing as that, which means your function has been shifted horizontally, right? Left or right, but you don't know. How do you know? You say my x plus 60 degrees is equal to 0. Equate this shift to 0 and solve for x. You find that your x is equal to minus 60 degrees. What does this mean? It means that your function f has been shifted 60 degrees to the left. So what we can say is that f is shifted 60 degrees left. That's what this thing means. So here's what you know or should understand, or you know by now, that your f of x was equal to g of x at some points, right? Your f of x was equal to g of x at some point where they were intersecting here at n. At x is equal to minus 75. They were equal. And at x is equal to what? It's equal to 45 degrees. And x is equal to 165 degrees. So these two functions f and g were equal at these positions. It is three positions. X equal to minus 75, x equal to 45, and x is equal to 165. They're equal there. No problem. So now, we want to know if both of these functions are shifted together 60 degrees to the left, where will they intersect now? Right? These two functions are now moved 60 degrees to the left. You want to know the point of intersections. So which means if you're shifting these functions to the left, 60 units to the left, these positions will stay together, but 60 units to that side. These two will stay together, but 60 units to that side. And these two will stay in the same position, but 60 units to that side. So the point of intersections will remain together for f, right? For f and f at x plus 60 degrees and g at x plus 60 degrees. But they will be moved 60 units to the left. Because when you shift a function, if you're shifting both of these functions 60 units to the left, because f is shifted 60 units to the left and g is shifted 60 units to the left. So these will stay together, but 60 units towards the left. That's what will happen. So what you want to do, you know that these point of intersections will still, this function will still intersect at similar positions, but 60 units from this, 60 units away from this. So what you need to do is to move this point 60 units to the left, this point 60 units to the left, and that point 60 units to the left, and say which one lies on the interval that you're given, which is this. So let's move this point 60 units to the left, right? How do we do this? Let's move. So your g at x plus 60 degrees is equal to f of x plus 60 degrees, right? So what you do, you're shifting these point of intersection 60 units to the left, because this is moved 60 units to the left and this has moved 60 units to the left. So if we move this one to 60 units to the left, what do? We say, okay, it's going to be x is equal to minus 75, right? Minus 60, because to the left, right? And the second x equal to 45, minus 60. And the third x will be x equal to 165, minus 60. So what we get? The first x value of the point of intersections of these two, this and this, will be at minus 75, minus 60. So it will be at minus 135, right? The second one will be at 45, minus 60 degrees. That is equal to minus 15, right? And then the other one is that x is equal to 165 minus 60. That looks like it's 105. Right? Then now, these will be the new points of intersection of these functions. These two functions, these shifted function will intersect in these positions. So it will be those same positions but shifted to the left, because that's what you did to the functions. You have shifted them to the left. So now is 135 on this interval? No. 15 on this interval? Yes. So this will cancel it because it's not. Is 105 there? No, it's not. So, because 105 is greater than 0. So these two functions will meet at x is equal to minus 15 degrees. And we're done with this one. So we move to the next one, which is 6.6. Okay, so now we're doing 6.6. And 6.6, they are saying, without using a calculator, determine the number of solutions the equation, which is that equation over there, has for x is on this interval, right? Clearly show all your calculations. So they want us to find how many solutions does this equation have on this interval. That is what they want us to do. And they want us to do this without using a calculator. How do we do this? To answer these kind of questions, you must try to relate what you see here, which is this equation, to the functions that you have. For example, if you look at this, you can see that this is similar to g of x. Can you see it? Because you see I have 2x and we have that 2x over there. That's the first thing that you can see. Right? The second one is this. What is this? This f of x, because we're given g of x to be equal to sine 2x, right? And this g of x is equal to this guy here. So these two are similar. And you're given your f of x to be what? To be cos x, right? To be cos x, and you found that your a was minus 45. So if you look at this, is this similar to that? Not much, right? But we know that we can expand this by our compound angle identity. And if you do that, you'll find that this is cos x, cos 45 degrees, right? Plus, it's going to be a plus. What is it? Plus sine x sine 45 degrees. If we expand this by our compound angle identity, because you know that cos a minus b, cos a minus b is equal to cos a cos b plus sine a sine b. It's the same thing that I did there. I applied that. And if you continue, you find that your f of x is equal to what? It's equal to cos x times this. What is this? This is 1 over root 2. This is a special angle. Plus sine x times 1 over root 2. That's what you have here. And maybe if you continue, you find that your f of x is equal to what? Equal to cos x over root 2 plus sine x over root 2. So, if you look at this now, and they're a bit similar. But the problem is this root 2 that you have, because you don't have a root 2 there. Right? But this one and this one were similar. But the problem is that this one had root 2 and this g does not have a root 2. So now the trick is to try to write this in a similar fashion as these two. Right? So if you can get rid of that root 2 in front, then divide by root 2 both sides, you'll be left with g of x, which is this, and on that side, you'll be having f of x, which is this. So what you are given originally is root 2 sine 2x is equal to sine x plus cos x, right? So let's say divide by root 2, divide by root 2, divide by root 2. So this and that go away. So this side you're left with sine x, right? Or sine 2x to be equal to that, which is sine x over root 2 plus cos x over root 2. That's what we're left with. What is this? What is this? This is g of x. Here is it over there. So it's g of x. And what is this? And this is f of x. Because you just showed that this is f of x. Equal to f of x. So essentially, what they're asking you, they wanted to tell them the point of intersections, right, of f and g on that interval. So you have f, you have g. Go just have a look there. So f and g on this interval, this one to this one. Where do they intersect? They intersect here at minus 75 and 45 degrees, because that's what they used to intersect. So what do you say? You say x is equal to minus 75, or your x is equal to 45 degrees. Yeah, that's where those two intersect. The goal or the trick is just to relate those two. It's always like that. Just try to always relate the two. And you'll be done, like I am right now. And I hope this question did make sense to you, as it does to me. I'm done with it. Thank you for watching. Cheers.